Hey everyone, welcome to a new video series. Now in this video series, we are going to be looking at Year 8 transformations and congruence. So I'm going to split this series up into two halves. So one is going to be looking at the different types of transformations shapes can undergo. So today we are talking about reflection. And before we even go into the maths of this, let's just think of the most common idea of reflection that is relevant to our lives, something that we see day to day. Now, you wake up in the morning, you go to the bathroom and you go and brush your teeth. So, you're standing over here and in front of you you have a mirror. Now, the mirror is probably not going to be this big, but when you're looking at yourself in the mirror, you see what we call a mirror image, right? So this is the original. This is you here. And there is an image of you as well over here. So let me draw that in a slightly different color just to sort of try to highlight this. And even though my picture doesn't doesn't show this as much, this image, from what it looks like to you as you look into this mirror, is exactly the same as you. It is identical. And it's facing back at you. So as you move, right, you look into the mirror, your reflection in the mirror moves as well. And the distance, for example, between you and the mirror, so from, say, here to here, as you move forward, it looks like your reflection gets closer to the mirror. As you move backwards, the reflection looks like it's going further away. It's almost like there's another you inside the mirror and it's moving with you. It's identical to you and its distance and everything changes as you do. So these two lengths are exact. Or let's use a more mathematical term here. This is equal. So this is, I know it's a bit of a weird way to introduce this topic, but reflections are something we see pretty much. If you live in a first world country, have access to a mirror, you pretty much are coming in contact with this every day. And I'm hoping this way, when we actually go into some of the maths and we put this on a grid line, for example, an XY plane, it'll still be relatively intuitive to you because of your day-to-day experiences with reflection and this idea of an image of yourself, this transformation of an original thing. So this original, if this was a point or anything, say I call, I don't know, my head here, point A. A formality that we use in reflections and transformations is we do the same kind of point, but we do this little apostrophe at the top, or some people call it A prime, for example. And this just means the same point. It's exactly identical, except it's just an image one. It's the reflected part of the real thing. Now, all reflections are what we call isometric transformations. So if I move all of this along, and I just write a little definition here. These are what we call a reflection is an isometric transformation. Sorry, that writing's a bit bad, but this just means the size of the object is unchanged. So size of object is unchanged. So if you look at yourself in a regular mirror, not one of these weird warpy mirrors you get sometimes if you go to like a carnival or something like that, if you look at yourself in a regular mirror, your image or the transformation of you is unchanged. It's identical to you. It's the exact same thing. I'm looking at an exact copy of myself. Now, all these same ideas apply when we bring some maths into it. So here I have a couple of shapes, and what we're going to do here is we are going to practice just drawing in these mirror images, these reflection transformations of shapes. And the way we do this is just by considering, well, where is our mirror and what is going to happen to all these points on the other side of the mirror? Now here, the line that's drawn here, that you can think of as your mirror reflection. Now, what I want to do is I want to reflect each and every one of these points in my mirror image. So if I think back to the idea of, looking at myself in the mirror, right? This point here, point B, that's going to be the exact same distance from my mirror line here, this pink one, but just on the opposite side. So I'm going to measure that roughly as here. So I'm going to label this point B prime. Just the same thing that we were doing before. And I'm going to do this for each and every one of these points. So this point C, for example, I'm going to roughly draw in where that's going to be. That becomes my C prime. Same with my A. That's a little further back, about here. This is my point A prime. And so on and so forth for my other points. So D is going to be below C, down here, D prime. And my B is going to be under my A prime. Whoops. E prime. And now all that's left to do is just connect the dots. So in doing this, I'm going to get a pretty good looking reflection of my original shape. Now, when you do this in school, you'll probably get grid markings and things like that to make your drawing way nicer. I'm just trying to draw this freehand, but you could kind of think of this and say, you can sort of see how this could be a reflection. You can think of it as this shape here is looking at itself in the mirror, and the shape on the right is what it sees staring back at it. That's what we mean by these reflection transformations. So we're going to do the exact same thing for this next shape here. And it's going to be a little bit weird this time because our symmetry line is kind of tilted. It's not perfectly straight, but we're not really too much to worry about because we can just continue with this idea of opposites, of reflection. So this, let's start with, for example, point A, right? This lies smack bang in the middle of my line of reflection. So my A prime is going to be exactly there. We can think of A as being no distance away from the mirror. So A prime will then be no distance away from the mirror. You can think of this at home. If you went up to your mirror and pressed your nose on the mirror, you are perfectly on the line of reflection. There's nowhere back to go. So that's why this A prime is going to look sort of like this. And our B prime, if we kind of draw this line over here to sort of reflect my B, I'm going to get B prime looking like it's right about here. Now, if you tilt your head on the screen, to make your eye line in line with this line of mirroring, you will see that this looks pretty much spot on. And we're going to do the same thing with C. So C is pretty far from this line, but if we draw in a little dotted line kind of all the way down to here, I get my C prime pretty perfectly opposing my original C along my line of reflection. So what I end up doing here is I just want to join all of these points together. And I'm going to wind up with a triangle that's pretty nicely reflected along this line. And if you turn your head, you'll be able to see that we get that. And as you're doing this for maybe some of these tricky ones, if you want at home, a strategy I like to do is I like to sort of just draw a straight line kind of directly from my regular points to my mirrored points, passing through this middle line here. And that gives me a good idea of where the image points are expected to go. Okay, so that is how we can start thinking about drawing reflected images. And as you can see, if we compare, for example, my first triangle here with my other one, it's been transformed. The C, instead of being here, transforms to there. This B goes to here, and the A stays as it is. We have transformed the shape here. Okay, and now we're going to move on to our next example. And some of you may look at this and just go, oh my God, like this is really scary. Now it's on a grid. I don't know what to do. That's okay. It may look a little bit trickier, but the same ideas are going to be true when we bring this idea of reflection onto a grid. And you'll see some interesting things happening with our coordinates here as well. We're going to talk about all of those as we go. But the main thing I want you guys to think about when you approach these types of questions is the idea that you've seen this before. You guys have mirrors. You've looked into a mirror. You have an intuitive understanding of how it works. So you just need to bring those principles in with you as you work through these reflection transformations. So I want you to do two things for me here. We are going to find the coordinates of A prime, B prime, and C prime when the triangle is reflected first along the x-axis and along the y-axis. So I want to reflect this along the x-axis to begin with. So this line here, you can like tilt your head sort of 90 degrees to the right or to the left, and you'll be able to see this line as being this vertical separating reflection line, kind of the same as this one up here. So what we want to do is we want to just identify where each of these points, A, B, and C, are going to be on the other side of this line. And you can probably gather by now, they're going to be somewhere in this section of my graph. Now, let's start. So my A prime, well, that one here is going to be the exact same as A. Same thing in that previous example, because it is right on my line of reflection. So my A prime is going to have the exact same coordinates of 1, 0 as A. Now, what do I want to do with B? Well, I can see that B is 1, 2, 3 units away from the x-axis. It's 3 units in the vertical direction. So to find where my reflected mirror image is going to be, I just want to go 3 units in the opposite direction. So 1, 2, 3 in the opposite direction. This thing here is going to be my B prime. Now, what's actually changed here? Well, my x coordinate is the same. Let's do this in the same color. For B prime, my x is still 2, but my y coordinate is the same as my regular B. So my image coordinate, my image point, the y is the same magnitude, the same value, but the opposite sign. And that should hopefully make sense, because think about when you look into a mirror, your distance from the mirror is the same distance as your image is from that mirror line. So it would make sense that that would be 3, but just -3, because we are in this opposite, we are looking at the x-axis as being this reflection line. So I'm going to be the same distance away from that, but in the opposite direction for my B prime. And the same thing is going to happen for C, because you can see C is 1, 2 units away from my x-axis here. So my mirror image should be 2 units in the other direction. Let's do that in the other color for some consistency. 1, 2. So this particular point here is my C prime. And when I connect all the dots here to here to here, I have that exact image. I'm drawing the same triangle, but just the mirror image in relation to my x-axis. So my coordinates of C prime here are going to be 4. The x coordinate doesn't change. The y is the one that changes. So it's the same distance down with the opposite sign. Now let's look at if instead of this, I reflected along the y-axis. So along here, for example, I want to figure out what's my shape going to look like on the other side. And I'm going to do this in the exact same way. Like, what I like to tell my students is when you see these types of questions, particularly reflections, just think this isn't the first time I've seen this. We've all looked into a mirror. We understand intuitively, due to our experience, how this kind of stuff works. So it shouldn't be too scary. Even when we put it on a grid and try to make it look all crazy, the idea is still the same. Now, I'm looking at my point A, and I see that it is 1 unit away from my reflection line. So my A prime is going to be that same distance on the other side. And for B, I'm going to do the same thing. Well, it's the same height up, but I want to measure, okay, there's 2 units on the X, so I have 2 units here. This is my B prime. And my C, I've gone 4 units away from my y-axis, so I should be 4 units along this way. That is going to be my C prime. So once we draw this in, whoops, oh, that's annoying. Okay. You guys will notice that this time, if I copy down these values, my A prime along my y-axis, the y-coordinate stayed the same, my 0 stayed the same, but my x, instead of being 1, it became -1. My B prime, the 3 on the y-axis stayed the same, but the sign of my distance in the x-axis, this 2 units, instead of being +2 on the x-axis, it is now -2 on the x-axis. And finally, for C prime, I have my height. I'm still at 2 from here to here, but the thing that changes is my x-coordinate. So the 2 is the same, but my x-coordinate, instead of being +4, that becomes -4. And in doing this, I've drawn 2 different types of reflections. And the reason these images look different is that our reflections will look different based on where this line of reflection is placed. But that is how we can think of reflection transformations in this video, and we will talk about the remaining 2 in the next 2 videos. Thank you so much for watching, guys. I'll see you in the next one.